4 o'clock. Are we good to go? Welcome everyone to session 22D, the last session of the day and the last session of the 17th edition of the CDOIQ for this year in Track D. We have with us this afternoon Pedro Caceres. Close?
Yes.
Okay.
Very nice.
He is the board member of Enotalk AI, and I will not read through his bio. He will introduce himself as a part of the session. And I would ask everyone in the room to please make sure your devices are on silent mode. Pedro, over to you.
Yep. Good afternoon, everybody. Good afternoon, all people attending online today and any future viewers on this presentation. First thing I'd like to do as well is to thank the Symposium for inviting me to attend and present this talk today. I've been attending these past 3 days and went through a lot of different talks, and I could see that there was a lot of sharing regarding data, the technical parts of it, many questions on the human side of applying and implementing these projects. But I now understand why the organizers of the symposium invited me to this presentation. And I'm bringing today a business view of data and business view of the use of all this technology to really develop and grow business. And I think that perspective is fresh and probably will be useful for all of you listening. So I'm going to talk about the union and intersection of business, value, data, operational models, and digital models. And one thing that we cannot forget is that at the end of the day, any technical or any technology has to be used for practical uses and business to be successful. So let's connect those things today and talk about data in the context of bringing business forward. I know I'm going to oversimplify some of the things and some of the concepts, but as I usually say, I always give CEO adjusted answers, which means that they need to understand what I'm saying, they need to understand what the implications, they need to understand what is asked to the business and how to resource it and implement it. So usually those answers are not highly technical, are very business-like. I'm also want to make sure that as far as I use the different concepts today, that I will refer to data as any fact that is used for computation or decision making. Structured data I will refer to as information, and then information that is benchmark of goes through semantic layer of meaning will be considered intelligence. So I make a clear differentiation when I am approaching all these different technology in application to business, when I'm talking about just data, when I'm talking about information, and when I'm talking about intelligence. And that connection needs to exist. Unless data becomes intelligence, is not very useful in decision-making systems. So let me introduce me a little bit more of who I am, why I'm talking about these topics, and then what is my connection to all these. So as you can see, I'm a mechanical engineer from the Polytechnical University of Valencia in Spain. I have all kind of continuing education. At the same time, I had held executive positions globally at Hasbro Games, also at Newell Rubbermaid, PetMate as the Chief Operating Officer, now our Cartamundi, running the collectibles and trading card games in North America. I'm also the creator of the ABC XYZ inventory model that many companies are using, but probably they don't know is copyrighted. And also, I'm the lead scientist in the creation of a new system of applied intelligence for supply chain that is called InnoTalk. So I bring the business side of the world, I bring the technology side of the world coming together in what I call, in the frameworks that I'm going to use today, part of the Industry 4.0 framework that has been developed lately. So I'm going to explain 7 different models that have been very useful for me in business. And all these models have a strong component of data. And it has a strong components on digital as well as operational content. So one of them explains the framework, a strategic framework that I use to implement these changes in organizations. Then I will go through simple models that have worked very well. Then more complex models, including the very important concept for me that is digital twins, and then finalizing with the model that is being built into InnoTalk system of applied intelligence. So let's remember that the main goals for business operations, and that is at the end of the day, the goal of every project that and every model that I develop for business has 2 components. One is always to enable the top line growth of the business and drive the bottom line growth of the business. Those 2 are the main things. The return on investment on any project, either digital, operational, or combined digital operational, must be measured against these 2 goals. As I said, there are strategic framework models that I'm going to explain and some tactical ones that are more operational. Why do I like models? In general, I would say that models bring chaos into order. It is a way of getting a very complex understanding of variables, independent, dependent, of time series, and all kinds of facts that come from the transaction history of a company. And at the end of the day, you're trying to make decisions regarding whatever in whatever aspect of the value chain of the company. So those data sets and the complexity of the feed, of the input into the model is always chaotic. Part of the data is structured, part of the data is unstructured. You can always never forget that Microsoft Excel is looking from the shadows, okay, of anything you're trying to do outside Excel. So that brings me to a concept that I call dark data. So dark data is like in the universe, dark matter. Exists is in many spreadsheets all over the place in every company where people analyze and make decisions that are not on the ERP systems. And that dark data, actually, most of the time unstructured, is not ingested into data sets that eventually will fit the model. So you start initially with all the pieces of history, all the pieces of execution that are needed to understand how any process have worked in the past and may work in the future is very uncertain, very incomplete, and usually very unstructured. So the model has to bring all that complexity plus the complexity of the science behind the application of the model into one simple order that can help us do one action or another, which makes these projects very, very complex. The first model that I want to talk about is the transformation network. So whenever I am dealing with a company, whenever I'm running any functional area of the company, there are 4 aspects that always have come to mind. If we want to move from being the traditional company that is just transactional, that the only data that is real is transactions made, not even the master data into the ERPs is accurate, right? You want to move from there to a company that is able to not only do business as usual, but also gain a competitive advantage in the market because they have a better understanding of the customer, consumer, trends, and everything back to creating the right product. You have to move from being descriptive to predictive. You have to move from, yes, nice charts and dashboards in Tableau, Quick, or MicroStrategies, or whatever, to what is the insight that chart is telling us. And what is the prediction we can make based on that chart, on that data, going forward. So moving from descriptive to predictive is a step that is completely necessary. The second one is moving from reactive to proactive. It's not only waiting for something to happen and react and fix it, it's predict that it's going to happen and proactively avoid the issues, mitigate the risk, and support with resources the growth. The third one is more complicated. It's moving from being a deterministic company to a stochastic company, which we, in normal words, move from believing that every fact and data that you have is permanent and will never change, to understanding that every single piece of data, right, in a high percentage, is just probabilistic. Companies cannot take the assumption that a lead time is fixed, that a production yield is fixed, that the attendance is fixed. Every single piece of data that resides in a company, in company system, dark data or structured data, every single one is probabilistic. And if you're not able to understand how to model the probability of that data, all your models will be inaccurate. Even if you compare trained data to tested data and you find out the accuracy and all the measures are high, the reality is that probably there is bias behind all that data that drives those results. But the reality is the probabilistic nature of that data wasn't considered properly. And the last one is move from being sequential to concurrent. The idea that, oh, I'm fixing this problem to pass it to somebody else or another functional area, fixing the other, that doesn't work. The reality is that the configuration of the data sets, data available, the information that comes from there, plus the models had to provide solutions that are concurrent to all the agents, elements, and entities that participate in the value chain of the company. So move from descriptive to predictive, reactive to proactive, believe that everything is uncertain and measure and attach probabilistic models to the data, and then move from sequential to concurrent. If those 4 things don't happen, then I don't see the path of moving from traditional managing of a company to really being in the new economy of that is just supported by digital technology. Very difficult to do, very difficult. And each one of these things requires significant change management training and resources and knowledge that are not easy to get today. This transformation that actually fills up the digital transformation concept is not and cannot be led just by CIOs. The thought process that CIOs in every company can now own both the digital and the execution of that digital into business is just not realistic. New functions like chief data officers that own part of these things, and chief transformation officers, or also chief technical officers, are really critical to get this new paradigm in place and then managing the changes of the business from digital, including data. There are some suggestions here for implementation. One of the things is the key master data has to be a company asset. It's not a departmental asset. It's not a functional asset. It's a company asset. In the same way the machines are maintained, and the accuracy of execution and the quality of any technical systems in the company, data has to just be maintained and curate, and eventually with the proper techniques and tools to be as accurate as well. Another good suggestion is never accept a chart from anybody without insights, right? Never do it. We all like the colors and the beautiful things. The reality is a chart without any insight is completely useless. All the processes in the company, all of them can be impacted by this. And at the end of the day, if you're looking at the value chain from the vendor to the customer as one entity that goes through this concurring way of working, you get the benefit. You get a benefit that is much, much higher than breaking those things in parts and implementing in an isolated way. So I'm not saying it's easy, but that is the experience I have. One of the frameworks for how to bring these things together that I'm very fond of is Industry 4.0. It has been just evolving. The reality is that you have, on the digital side, horizontal and vertical integrated, all cloud-based kind of systems, all the data lakes, blockchains, and everything that has to do with the availability of the data as an asset. Then all the Internet of Things, Internet of People, the ability to sense the world, the physical world, and bring it to the digital world. And then the cyber-physical systems integration, robotics, additive manufacturing. All these digital layer connects to the business layer. And the way of connecting these things on the business layer with end-to-end, completely value chain analytics, smart factories, and end-to-end integrated business planning, as some examples of the operational part of the connection. When you can bring all this together under a framework and paradigm of data models and execution, this is the end result of really a full integration, right? There are many developments happening here. Smart factories are just coming along in some different places, and it's very exciting to see the results they're getting when they are absolutely able to do predictive planning, integrated business planning, all through that is executed through cyber physical systems, and then with Internet of Things that can bring back the information to the system and realigns the system and adjust the parameters to perfect execution with very, I would say, constraint-driven sequential planning of factories that connects to the sales and operations process. All those things together right, is what increases the efficiency, exponentially. Some suggestions for the implementation of Industry 4.0, in my case, has to do with the hierarchy of all components of the entity. The hierarchy from equipment in the factories to entities in the supply chain to components of the digital marketing strategy or execution of an e-commerce strategy. The classification, the framework, the creation of all those things helped tremendously. The data engineering around those things and deciding where and how to get the sensing capabilities in the process, and sensing capabilities, and the entire concept of sensing and responding is actually, and the speed of that sensing and responding really drives execution that is just at a different level from what it used to be, forecasting 3 months, 6 months, 12 months, executing, reviewing things a month or two later, making decisions, that's over. Okay, sensing and responding, creating the pipelines of the sensing into the system, into the models, execution, and then control of the execution through data engineering, data science. So there is a way of applying techniques that exist today at different levels of complexity and progressively more and more complex to start driving this framework of Industry 4.0. The problem is companies don't know where to start, how to implement it, how to measure, how even to know if an investment is really returning. And all that thing in complexity is something that has to be understood and really planned and organized before going in. One of my favorite subjects is the digital twins in supply chain, digital twins in general. Yeah, I could make the affirmation, and I really believe it, that what doesn't exist digitally cannot be controlled physically. Right? You're not able to get the entire definition, execution, or control of a system mapped into the digital world. And when I say map, it's completely real time, and no transaction in the physical world is not mapped into the digital world. If you are not able to do those things, the possibilities of really optimizing any system is just inexistent, right? So this is a digital twin that I created that went from supplier management to replenishment and trade management with the suppliers, production planning, sales and operations planning, inventory management, into transportation management system, warehouse management system, the demand planning, order management, and customer relationship management, from end to end. And these are the systems that were used for that, from ERP iSupplier to an iContainer system, from advanced planning, sales, inventory, and operations planning, integrated business planning, to WMS, product flow, advanced planning, ATP. All those components of different systems came together to be able to sense the execution and then to adjust to that execution on real time. So a change in the order from a customer one particular day, we could understand the impact that would have in a supplier even months later, right? Or a supplier not running a machine one particular day, what is the impact of that supplier failing with the delivery that is planned for weeks later in the US, right? So all these end-to-end visibility, end-to-end understanding of unsensing any change, and I have built models that helps me make decisions on how to mitigate that problem. This was one of the tools that made us more successful through the pandemic time, when all parameters in the supply chain were changing constantly, globally, and the only way was to be able to sense, respond, and execute in a continued basis, right? So very strong. I really believe that this is one of the models that will benefit most companies if they're able to start building digital twins for different aspects of the company and connect those digital twins. For instance, there's another digital twin on the product development in R&D. There can be a digital twin in areas that had to do with just manufacturing execution, and at the end, all those digital twins create the fabric of the Industry 4.0. Digital twins enable end-to-end visibility. They enable integrated business planning of all the entities in the digital twin. Provides answer to critical questions that can impact any of the elements or entities in the digital twin. Enable sensing and responding. And one concept that I'm going to explain now later, which is this concept of homeostatic supply chain, able to fix itself without external interaction, right? A simple model on the ABC XYZ, that was one of the first models I ever created in 2009, is like we're looking at things in the basic foundational data of a company. We're looking at things most of the time in one dimension, in one deterministic dimension, which means that we classify things based on one variable, we assign a value, and that value doesn't change unless there is a tactical plan of having a person reviewing those things on an annual basis, right? And then we live with that. We know that reality is different, right? But we live with that. We make decisions based on that raw data, and we then manage whatever comes to us, right? So we over plan, okay, so let's correct that. But we're gonna damage our brands. We're gonna discount, we're gonna do things. Or we went too short. Okay, so let's try to fix this, and we're gonna spend significant amount of money just try to get the product, right? And when you are in that ups and downs, because you are just managing raw data, it really hurts the business. But as long as the EBITDA is in the goal, nobody even thinks that it could have been much better. Reality is that this system, what it did at that time is, okay, let's start to look at any items that we have in our company, and then let's try to consider that item lives and has many multiple different characteristics, not just one, right? The volume we sell is one parameter, but how variable is that item in the marketplace, measured by the standard deviation of demand? That's another variable. Actually, you can have n different variables. A matrix here that is just a 3 by 3 could easily be a matrix of m times n to the n, actually. N variables with m different values, n to the m, right? When you do that, and then you decide, I'm going to manage the company based on groups of these variables instead of just one. So I'm going to discriminate between different types of companies within the company. I'm sure the e-commerce side of the business that has a high variability and low volume is different from a domestic retail business that has not as much variability and high volume. So are our systems prepared to manage all these complexity? If people cannot handle more than one-dimensional vector of data, how can we expect that it can handle a multi-dimensional matrix of data for every item, for everything, and then apply to each one of those dimensions a probabilistic distribution, right? The complexity, the mathematical complexity of dealing with all this is so high that is not possible to be done by humans, right? So the advance of the technologies that we're now starting to see with machine learning applied to predictive analytics, we're getting more and more AI methods just coming in to try to solve some of these things with the problem of not understanding the solutions, because there's no way we can know where the solutions come from. All those things are very effective in the transformation of the company, but very difficult to implement. But this initial model in 2009 was very useful and delivered a 17% of reduction of inventory doing things the same way, which was very meaningful. This is an example of application where there was a clearly, and you will see that in the final writing of the presentation, how the improvements happened. And as I said, 17% reduction of inventory, just applying this in 1 year. It was very, very useful. We come to the concept now of homeostatic supply chain. So we have defined that the data that is used in a company can be modeled to represent a more complex real, both definition of the entities, products, and processes, and also from being more predictive and stochastic than we have today. That's been defined, right? So you can say that it's an organism of data. And that organism of data, like ourselves, whenever something happens to us, our body reacts to that and fixes this and try to bring it into equilibrium. So can we define supply chains that when those external and internal things happen, they can automatically, based on the models created, readjust to make sure that can mitigate that impact without human intervention, right? We are already able to sense. We're already able to create response mechanism. We're able to predict in a probabilistic way what scenarios we might find in the future, and we have an understanding of the variability of each of the elements that are part of all that complexity. Can we define in a way what we can call external or internal sentiments that based on those things we can react to or let the system react to by itself, right? So this is an application actually used on a simple way of homeostatic analysis of a supply chain. So what this is showing is different variables and their trends and understanding, and including point of sales at the store level and everything that you can imagine. And then the system, the model was created to define an external sentiment, which means what is the customer thinking or feeling about this particular item, and what is the internal sentiment. What is our company thinking or feeling about the company? When those things are not aligned, then there is an issue. So when you have an internal sentiment of 1 and an external sentiment of 1.6, you might say, I'm okay. I'm going to create a model that if the difference in sentiments is no more than 50% or 100%, whatever you read it, there's no reaction. But there was an activation rate calculated based on that difference. So without human intervention, and with all the parameters of the supply chain being sensed, inputted, all the data present in the system real time, then the ability of the system to say, you are not seeing and understanding this item the same way your customer is. Then, at that time, the system has to react. And the system reacted, and this activation rate was attached to different levels of execution. You're supposed to do this, or do that, or do that. So there is a reasoning AI behind this concept, right? So, and when I apply I use the word reasoning AI, at this time is very well known that the system, through its own build, can reason and make a decision, a suggestion, an implementation, even an execution, or certain things. You could even tie this to RBA or any other type of technology to get this done. This was a real implementation. The concept of homeostatic supply chains in business, coming from the digital world into the operational world, is powerful. At the end of the day, the main thing is creating systems of intelligence, right? So this is a very simple way of defining what that is. There's a business problem, there's a decision-making model. When I know how I make decisions, then it goes to the digital world. The data science, data engineering, piping the data, eventually visualize and operationalize, all those things. But this is a very simple way of, everything starts with the business has a problem and has defined the decision-making model. The data, for the sake of data, has no sense. The data has always to exist because it's going to be feeding through a semantic layer into decision-making models. And this is a mathematical way to say what I just said. It's not about data for the sake of data. It's not about applying machine learning or getting all the data you want into the external world and somebody will find out what to do with it. No, it's about exploring on the entire universe of decisions. Okay, which one is the best to optimize the solution, right? It's all about decision making. And then I come to the last one, which is Ignotalk AI. So the big problem to solve here is ERP systems are using master data that is deterministic, incomplete, and inaccurate. And we're using those ERP systems to plan our companies, eventually to schedule execution and to control. The deviations of that reality from the master data are enormous. So, Ignotalk AI as a concept was born with the idea is, can we dynamically, without human intervention, understand what the real execution and performance is for all the elements in the supply chain, and can that automatically update master data in all the systems, in all the ERPs, and any other functional systems at the company? Can we see what actually is happening? Can that be from a stochastic probabilistic model created? And then can that automatically build back into the master data for the ERP system, so the system learns every time that any execution happens and brings the information back to the ERP, and in a homeostatic way, start learning and creating the accuracy of planning execution higher. It's based on sensing and modeling. The system is able to sense reality versus any assumption made in the past, is able to model the variations, is able to model the uncertainty. It calculates what is eventually the cost optimal plan for every part, optimizes the service levels and fill rates concurrently, and is able to update master data on the ERP systems to get improvement in accuracy and performance, and provide the total cost, not just the ex-factory cost, the total cost of what it means to get that item to the marketplace. Uses a real world approach because it models volatility, uncertainty, and complexity. Uses better supply chain models, not just the simple models that ERP systems have. It makes dynamic calculations. It's not just basing in calculating for a certain lead time. It breaks down the entire value chain in blocks that are dynamically calculated and dynamically changing based on a dynamic change of master data through. And then supplement all the ERP shortcuts that we know are completely incorrect. The entry data is all about past planning, past real execution, whatever level of details are. That's the original master data. And then the original forecast from the first day. And then when that is ingested by InnoTalk, it just uses that path for the first iterations of the system, and it runs on a continuous basis. But when it gets to 2, 3, 4 months later, okay, that data stays in the past, but is already using all the ingested sense execution and variations. And at that time, the system is feeding itself to create all the parameters going forward. So you ingest things once, and from there, the system ingests continuously and doesn't need to go back to do an ETL. On the past, it's done just once. The ETL it transformed from ETLs, extraction, transformation, and loads, into ingestion directly. The outputs are many different outputs, but in every case can create optimized solutions, are compared to any other, are compared to your current strategy, how you flow in product through your value chain, compares to evolution of costs through the supply chain, and in any case provides an optimized flow plan for every single product SKU at any level in your bill of materials. It gives you at the end what is the total cost of ownership based on InnoTalk compared to your current, and it tells you how much money you will save by implementing optimized dynamic planning. And in this case, the example is just showing the savings, but the savings that we usually see when we are running this are an estimate 18 to 25% impact on total cost of ownership, which is significantly high. So we're coming to the end. As a recap, and I think we're going to have time for some questions, right? 15 minutes, yeah, we did well. So as a recap, have a framework for transformation, and I propose one that have worked for me. On that framework of transformation, make sure that you create digital twins that are able to simulate, experiment, optimize, and test anything on the digital world. And then from there, create a homeostatic models that are able to self-adjust it themselves to get things done. And as an example of this, you can always check InnoTalk AI at innotalk.com, where you can see how this all comes together for supply chain execution.
Thank you so much, Pedro. Really appreciate that insight and all of those models. Really fascinating. I know I did some research last year at IDC on basically connecting the IT data to OT data and how all that comes together. And so seeing this happening in the supply chain is really fantastic, and seeing real solutions coming forward. I have to get you connected with our supply chain analyst at IDC. We do have a question online.
Yep.
The question is, what is a good approach for building a data model that is flexible and adaptable for a dual velocity, digital twin-like enterprise business and operations model?
Yeah, it's a great question. It's a key question. Okay, the way I do it, okay, usually, is, and it is, I create like a universe. What is the universe of data, right? So there are some stars on that universe. Okay, stars like supply chain decisions, right? Or engineering or product development. That star has planets around. For the supply chain, I need vendors and customers. I need POs. I need item master data. I need all those. And from each one of those planets, there are moons there, right? So everything starts with decision making. Everything. So the problem is, for me, first, is and let's say start with supply chain, and we start with planning, right? And the question to ask is, need to have a system, a planning system, right, that can give me a certain levels of metrics on inventory levels, total cost, fill rate to customers, okay? The three components of the supply chain. I say, okay, for that planning system, okay, if I need to make a decision, if the plan I'm given is the optimal plan, what do I need to see? And when that happens, I say, okay, so I need to see fill rates. So for the fill rate, I need to see the orders from the customers and deliveries from the past and orders from the future. So I go one by one and start building those suns and planets and moons. And then I start with one question in one of those things. When another question comes up, I start building more stars, planets, and moons of data. And I keep adding to that. And I do it sequentially. I want to answer, the only thing I want to answer my first 3 months is my plan optimized? Am I using with what I know from the past and the future predictions? Am I approving today the best plan I can have to deliver the items to the customer at the best cost? So for me, the answer is create those questions first. Where are you asking the data to answer? When those questions are clear, okay, choose one of them. You'll choose the other later. And create the universe of data, which is partial only, to answer that question. And through that first creation, okay, set the standard for your data lake, for your piping, set your standards for the data engineering, and set the standards for the data science. So in my case, I can say, okay, I have Oracle, SAP, whatever. So that base of transactional systems are going to be extracted this way. I have other systems, functional systems like planning systems or whatever, going to be extracted this way. And then the data lake is going to have all these pieces of data, and my answer based on a semantic layer of the answer to this question needs to have this specific calculation, right? And when you start defining those standards, start adding and adding and adding, okay, this is very agile, right? Then you start just building up, building up, building up, and accelerates at one moment in time. Yep.
I think that's great advice. Always start with the question or start with the decision that you want to make.
Yes.
Work your way back from that. I don't know how many times I've had people ask me, they wanted to start a new initiative. How should they start? My question is, well, what's the business problem you're trying to solve?
Correct.
And they scratch their heads. Well, then why are you trying to do this?
Yeah.
So thank you very much, Pedro. I don't see that we have any more questions online, and we have no questions in the room. So thank you very much, Pedro, for your insights this afternoon. For those that are online, if you are planning to attend the town hall session, that is kicking off in 9 minutes. And I don't know if there's a separate Zoom link for that. There probably is. I don't think it's something that's on Whova, but if it is on Whova, then it's on Whova, but I don't know if you can attend it on Whova. So anyways, look for details on how to attend that. And thank you very much. This closes out track D at this year's 17th annual CDOIQ Symposium.
Very good. Thank you so much.